What materials would you expect to use to make a watch? Glass, aluminum, plastic, I don't know, maybe leather for the strap? Well, the two designers we're about to meet had different ideas, inspired by the urban materials around them.
So Denise, if you look up, this is actually where we got our inspiration from for Aggregate.
The Transamerica building?
Yeah, so it's actually not the building itself, but the material the building's made out of. The concrete was actually the most important element.
It's hard to imagine going from a big building like this to something that's small enough to wear on a wrist. You guys are crazy.
Mike said I was crazy too.
And so is this a concrete watch on your wrist now?
Yes, the bezel and the dial is made of concrete.
It seems like it would be really heavy to wear.
You would think, right? But steel is actually more dense than concrete.
So I think in everyone's mind when they hear concrete, it's like they're thinking building heavy. That was kind of the playfulness of it, is taking something large, the idea of it, and putting it into something small and elegant. We kind of like to think of it as architecture on the wrist.
I love that.
So is this regular concrete? Can I just buy this at my hardware store?
This is not conventional concrete. This has a much higher strength to weight ratio, and it's much denser than regular concrete. We're ready to go.
This is really delicate work. Do you make all the watches like this?
Well, we started this way because we had to learn, but now we have a team overseas.
Here we have some of the CAD and the 3D files that we actually use to design the watch prototype. A lot of times when you're working with overseas factories, there's a lot of challenges in communication. Basically, we worked a lot of those kinks out, and that's how we ended up with these production models here.
Can I try one of these on?
Absolutely, please do.
I love this one.
This is the gravel gray, actually our most popular model. When we designed them initially, we really wanted the colors to be unisex.
This is concrete, right?
That is the concrete bezel, and because we knew that concrete is not like metal, it's gonna wear over time, and so we wanted to design a way so that you could replace the bezel.
Cody, Zach, now you are the designers behind this particular innovation.
We are. We're actually naval architects, and we were tasked with designing all of the underwater hydrodynamic surfaces.
We actually designed the planes with the same software used to design airplanes, and the shape comes about as effectively optimized for the physics of the water.
So you've designed this so anybody can use it?
Well, if we've done our job right, we've designed it so that your brain is smart enough to control it just after a couple minutes of practice.
It's almost as if I become part of the mechanics of the device.
Absolutely. You're effectively flying, and your weight is controlling every movement of the board.
So, David, you've got me in a wetsuit.
But Paul, we've designed this so that anybody can use it. You just need a little bit of courage, and I'm very confident I'll get you up and flying. Okay, now we've got a very big battery in here that can power you for up to an hour and a half for about 18 miles of continuous flying.
Wow.
Yeah. And of course, we've got a hand controller that allows you to control the speed of the board.
I see. So, stop and go?
Stop and go, cruise control like a car with these buttons. What we're going to do now, we're going to get in the water, pull this trigger, jump to our knees, front foot forward, stand up, and then, Paul, you're going to be flying.
So this is one example of a thing we call generative design, which is a new approach to automatically creating really, really lightweight designs like this. And this over here is another example. So this is a aircraft seat. And we don't just work with aircraft companies, we also work, with things that fly and things that go further out there into space.
You mean like NASA?
Exactly, yeah. NASA JPL is one of the projects we're working on right now, and they're trying to search for life beyond Earth.
Danny, you're the lead designer on the lander.
That's correct, yeah. So I was working with the JPL engineers, and we were trying to capture all of the design goals and constraints and putting them into our software. Things like the manufacturing method, the material, and we take all of that data and we generate a lot of solutions for the problem. So this is one component of the lander, and we've generated several options for it.
I would think that would take a designer usually a lot of time to do that.
Well, you wouldn't. You would come up with just one or two of these solutions. And so by letting the software generate all of the options for you, you're much more capable of making those upfront decisions. And so we generated some solutions for the lander, and then this was the final one.
Wow, that looks so sci-fi.
Yeah, because it's not designed by a human. And it's not symmetric because that's the most optimal shape. So do you want to go see it?
You mean you've made this in person? It's not just on the screen?
Yeah, we manufactured it.
It doesn't look like anything that an engineer would have designed with all these crazy shapes because the algorithm has said you don't need all that material. But we've got metal parts, we've got, what is this?
This is metal as well, but this one is cast. The legs are CNC machined, and then the internal structure is additive. So the acrylic box is going to be a radiation shield. It's going to be made out of metals. The radiation shield, we will have all of the scientific instruments to do research on a different planet.
So the lighter weight, the more weight they could put actually into this compartment to do the scientific experiments.
Exactly. Because we were leveraging generative, it also means that if the design requirements change, you're able to adapt a lot more quickly and generate a new design faster.
Well, what's the issue if they miss a deadline?
The launch window happens, maybe every 2 to 3 years because they're literally waiting for the planets to align.
So what do the engineers think of this? Is this a success?
Yeah, they were blown away. Typically they achieve 10% weight reduction. Here we got around 30 to 35%.
Wow, that's a huge savings. And you did all of that with generative design. Generative design is a step towards the AI future. But in this future, artificial intelligence is augmenting human designers, enabling them to try more options and ideas than they would have ever dreamed of.